Hi, John,
Hey.
and welcome to the podcast.
Well, thank you.
Just to start over, could you please present yourself? How long have you been with Lenovo? What Lenovo does in terms of AI technology? And then we can start right off.
Sure. So, John Donovan, I am the GM and Executive Director for what we call our Next Wave CSP. That is all the Tier 2 and Tier 3 CSPs worldwide. Been with Lenovo for 10 years and previously with IBM 10 years before the acquisition of our x86 business from IBM to Lenovo.
Okay, got it. So we're here to talk obviously about AI and especially about the liquid cooling solutions.
Mm-hmm.
And so from what we are seeing, AI has seen an increasing amount of attention over the last 2 or 3 years. So I think it was quite abstract what AI was before ChatGPT came to life and became available to everyone. I think everyone saw like the Terminator and like all the movies, and that's basically the idea they had about the AI.
Right.
And so with the rapid increase in usage and in power, we have seen that there are some challenges that came with it. And so we have seen the different solutions for cooling because AI needs cooling. So can you please explain some solutions that exist today?
Sure.
To start off.
Well, I mean, traditional servers have been air cooled, right? And so air cooling is good, but it presented some challenges. All right, if you look at things like fan power consumption, I mean, that could be anywhere from 10 to 20% of your power consumption just to move air through the server to actually be able to cool that server. As you start to go up in power, like we're seeing with some of these AI type of solutions, we need to get more efficient from how we remove heat. Liquid cooling and direct to chip liquid cooling is actually a much more efficient way of removing that heat. And so you're seeing the amount of power that you have to use from a fan perspective go down, and now we're able to put that towards liquid cooling in a more efficient way of cooling.
And so do you think that in the coming years, as I believe that we agree that AI will take more and more place in our lives, so we will need more and more needs. So do you think that the liquid cooling would be the standard or the best solution to implement in data centers and for all the cooling of chips, etc.?
So as you look at it from a standpoint of where we're seeing, in particular, the large language models going, and the larger and larger language models, and the ability to actually leverage the technology to actually go through and create tokens and create the amount of power you're going to need to really distill down that data for AI, you're going to see power increase, right? We're seeing it from this generation to the next generation where things like the GB200 NVL72 that's coming out from NVIDIA will be 135 kilowatts to the rack. That's going to require liquid cooling. And so as you see these large language models go up, you'll start to see the need for liquid cooling become more and more present, particularly on that training side of the business.
Yeah, from what I've seen when I started looking for, researching the subject, in the past we used to have liquid cooling, and then we switched to air cooling, and then we are going back to liquid cooling now. So I guess the question is, what innovations have driven these changes, and basically why are we going back? Especially with Lenovo, you have been at the forefront of this solution for years now, and so what major changes have driven the fact that we are going back to liquid cooling now and that we are finding it more efficient?
So when we say we're going back, I mean, really, liquid cooling started in the mainframe space, right? And that was probably 30 plus years ago. In the x86 space, we've really been looking at cooling, liquid cooling in particular, for about 20 years, thereabouts. We started working with liquid cooling back in 2005 with rear door heat exchangers, right? Simple idea around putting something in the back of a rack to capture that heat and using liquid to remove that from the data center itself. 2012 was really when we first started to work with direct to cooling or direct to chip liquid cooling and that type of technology. and really putting liquid inside of the server itself from an x86 perspective. From there, it's really gone into understanding what components you can actually cool, how much cooling capacity you could provide to that overall server, and really kind of driving out the efficiencies of how much heat capture you could gain over the last 20 years. Right?
Yeah, and so it might seem like a dumb question, right? Because so when we talk about liquid cooling, I think most people who have heard about this for the first time would have tendency to think that water would be the main liquid to use for cooling. Is it the case?
For us, it is, yes. I mean, right now, you're primarily talking about either all water or some type of glycol mix.
Yes.
And so from a Lenovo perspective, we've really focused on the water aspect of it. Water is a better transmitter of heat. So to be able to remove heat, water is a much better solution to use. And from a environmental perspective, it's actually much safer to deal with if you have to change that water out and things like that.
Yeah, and so now as we talk about this, so we know that water doesn't go well with electricity. And so the other question that follows this is the fact that how do you implement water? Does it require more maintenance? Does it require more attention? Does it have more risks? And then once you have answered this, how do you mitigate these risks, and can you reassure people basically working within the data centers?
So again, like you said, introducing water into a data center for a lot of folks is new, right? The first thing I'll point out is it's not new, right? We've been talking about this for a while now. So understanding the history of liquid in a data center is key for making sure people get more comfortable with that idea. Right now, from a technology perspective, there are a lot of things that we do to actually make sure that we don't see water in the data center. There's no leakage. Things like the materials that we actually use, the testing that we put behind that, the processes we have inside of our manufacturing plants, all are key to making sure that when our customers get a liquid cooled type of solution, they're not actually going to have to worry about that from a leak perspective. There's certainly maintenance aspects to it, right? We work with our customers. We test liquid, we test the water quarterly, and then we ultimately work with our customers, do maintenance on their CDUs on at least a yearly basis. So a little bit different in the air, but certainly something that's manageable.
Yeah, and so when you implement the water cooling solutions, are your teams also part of the maintenance team that comes to check, or do you also provide some education for the people working in the data centers as well?
So the answer to your question is yes to both, right? And so again, obviously, education is key for everybody to understand this, right? And so why do you want to do that maintenance? What could happen if you don't? Things like that. But we will provide that, and we highly recommend that people take us up on that service aspect. We will go in, like I said, quarterly, test the water, and then ultimately do those maintenance on a yearly basis.
Okay, got it. And so over the years, I believe that you do not come to this solution like at the first test. So basically, I believe you have a search lab to implement this. You have to run tests. Around it. And so what was like the way like that you have taken to get to where you are today? Like any highlights or to share around it?
It's definitely been a journey, right? And so one of the things that I like to highlight with our customers is, again, because we've been on this 12-plus year journey, there's a lot of learnings that happen there. There's a lot of materials that we've looked at that work better than others. And so it really starts with our design team and the ability for us to work with our partners, both in that liquid cooling space as well as those folks who are designing silicon, understand what the requirements are there. That goes into then how do we actually do manufacturing, right? When we ship out racks and we ship out servers that are liquid cooled, what are the test processes, right? We test for leaks. We actually do, we fill lines with nitrogen and test pressure over time to make sure that you don't see a drop in pressure so that there's no leaks. And then ultimately coming back and working with customers on their data center design and maintenance, right? So all of these things are things that we've worked with across many, many years to make sure that as we go forward and look at how we design cold plates, look at the materials that we use, look at the manufacturing processes and the services aspects, how we can make people more comfortable with this, and then ultimately help our customers to implement it, because it is something new.
Mm-hmm. And so in a world where we actually care about sustainability, where we are trying to shorten the process the most from the first piece that is produced until it's implemented and it's actually used. So Lenovo has a huge engineering legacy and a huge engineering capacity. So can you walk me through the process? So from the fabrication of the materials to the production of the cooling systems until the implementation, how does it go through?
And so if you look at it from a standpoint of the sustainability aspect, right? Obviously, when you start looking at materials, again, Lenovo's got a very rich history of looking at sustainable materials in all of the stuff that we do. When you look at the design aspects of what we're trying to implement, one of the things that's been key and really a foundational design model is how do we leverage liquid cooling at higher temperatures, right? So the ability to actually cool at 45 degrees C, right? The higher you actually are able to design from a cooling perspective, that liquid coming into the server, the more sustainable it is from an environmental perspective, the less amount of power you have to do to cool that. All right, and so as we look at how do we become more sustainable, or how do we help our customers become more sustainable, it's really around the design elements of the materials that we're using, and then ultimately our principles around how do we actually leverage warm water cooling to reduce the amount of power you need to actually cool that water.
Okay, and so regarding the scale of cooling, so basically if we talk about scalability, if we can imagine a data center which is cooled with fans all around the place, it seems like it could be like the easiest solution, right? But then on the other hand, how do you ensure scalability with liquid cooling solutions? Because you would need water, basically, which is stored somewhere, and then it's implemented into the cooling of the chips, et cetera, et cetera. How do you ensure scalability by implementing the cooling through liquid?
It's interesting because there's certain aspects of technology that you can't run on air, right? So the scalability you lose by just actually being able to try to run air from a standpoint of that perspective, right? Now, all your data centers have liquid cooling. It just happens to be in the air conditioning that they're using to cool that overall air. So how do you leverage that to actually direct that cooling to the actual servers themselves is really where you can get that scalability from a standpoint of management of liquid. Now, again, it does require facilities set up for this and understand how to implement that, but ultimately your water and your cooling is already there from a data center perspective.
And so what we are seeing is NVIDIA is the leader today in the GPUs and in all the computing solutions. Mm-hmm. And so it's all about concentrating as much power as possible in as little space as possible. And so it has a lot of power density, if we can talk about this. And so what is NVIDIA's standpoint on liquid cooling? And I believe you're working with NVIDIA. Mm-hmm. And so can you please elaborate more on your partnership and what you're doing together? So
again, NVIDIA and us are very close partners. We work with them on a host of the different solutions that we're both bringing to market. When you look at the GB200 NVL72 that we talked about before, that's the next generation of Blackwell that they're bringing to market. That is a liquid-cooled solution, right? So you will only get that in liquid cooling. And so to your point, right, as we're seeing these models go up and the power and the compute power that's actually required to manage a lot of these models, liquid cooling is going to be key for that. We see that in GB200. That's about 135 kilowatts to the rack. You can't run that with air. You can't get that kind of density from an air type of solution.
Okay. And so as we see, we've talked throughout the day with various people here, and we've seen that data centers have to adapt to AI power and AI computational needs. Mm-hmm. And so for that, we need data centers. Some data centers have to renovate and be able to sustain the need for computation. And then we have new data centers which are built every day. And so are you seeing more and more liquid cooling implementations is in these new data centers or in those who are converting towards AI?
In the last 12 months, I have talked to more customers about liquid cooling than I have in the first 19 to 20 years of my career. It is certainly a trend that we're seeing, and certainly one where a lot of data centers that you're seeing, particularly new ones, are actually adopting liquid cooling, right? And there's multiple reasons for this. I mean, the AI conversation is certainly one, but there are government regulatory issues that are coming in requiring data centers to be more efficient. And so when you look at it from a standpoint of the rationale for bringing liquid in there, AI is certainly a factor, but it's not the only one as well.
Yeah. And so we have seen that AI is managed by mainly private companies. So each company has its own goal of profit today. It can be the AI itself or services related to AI. And when we think about AI, it should be public good where it should benefit humanity the most. And basically, we achieve the best results through collaborations with various companies. So can you talk about your partnerships that you have in this space, about how these partnerships translate into innovation, etc.?
Yeah, so if you look at AI, first of all, again, AI, when we talk about AI as a whole, it needs to be treated responsibly, right? So, I mean, there's an aspect there where, again, we've put together a committee of folks that actually have provided a pillar, it's actually 6 pillars, around how we actually work with our AI partners as well as developing AI internally. It's things like transparency, diversity and inclusion, social and economic type of impacts. So we use that to govern how we move forward with our AI types of solutions. And then to your point, this is going to create the ability to advance AI is really going to require many folks coming together, right? Folks like ourselves and NVIDIA, right? As we mentioned that earlier as being a key partnership, along with the data center providers, along with the software and ISV providers, storage, networking. They're all key components inside of that. And so we have key strategic partnerships across all those areas to really help us to deliver a holistic solution from an AI perspective.
And are there any reasons for data centers? So if we're looking forward today into the future, are there any reasons why some data centers may not want to implement liquid cooling for various reasons? And for those who are still hesitant, who don't know if they should pivot towards liquid cooling, do you have anything to say about that?
Well, I mean, again, data centers and the folks who are providing data centers and building data centers out have their rationale for whatever they're going to cater to from an end customer perspective. Certainly where we see, again, the rise in AI in the large language model and the training portions of it, there's certainly going to be an aspect of cooling and liquid cooling that needs to be incorporated into those new data centers. If folks are on the edge and they're not quite sure what they should be doing or looking at, I mean, my number one recommendation is reach out and partner with somebody that you trust and has background and history in this space, right? The number one thing that you can do is not actually rely on this and have this journey by yourself, right? So talk to the folks out there that have been here and actually have helped to advance some of this technology, and a lot of them will be happy to help you, including Lenovo, obviously. But that's I think something that'll be key for most folks to do is really to try to leverage that community.
Yeah. And for the advancement and the development of liquid cooling, what do you think are the biggest challenges today?
I mean, right now, the biggest challenges are going to be the knowledge and the learning curve. Right? That's going to be one of them. And two is, again, to put a new data center in takes a lot of resources, capital, and time. Right? And so getting the amount of data center space that has liquid capabilities is not going to happen overnight. Right? And so it will happen, and it will happen over the longer term. But it's something that'll take 2 to 3 years probably to build out a larger capacity, a larger percentage capacity.
I think it's something that we have talked about throughout the day. Is basically that with the advancements of AI, of chips, et cetera, we still need more engineers. And these engineers have to have the proper education to be able to tackle these challenges and to respond to the growing needs of AI and all the engineering that goes along. And as we need more engineers, the education needs to follow. And do you think that today engineers are already really valuable people, developers as well? Do you think that we will still see the growth, the growing need of this type of education in the years to come? And do you think that something about the functioning of AI, of liquid cooling, should be implemented in their education today?
Well, I mean, again, when you look at, first of all, engineers, they're some of my favorite people. And so, again, at Lenovo, we value and I value our engineers very much. I mean, they are the backbone of what we do from a technology perspective and will continue to be in longer term, right? And so when you talk about liquid cooling and things like that, I mean, a lot of your thermal engineers and your design engineers are in, double E's and things like that are certainly going to have to look at how to deal with the power and heat that's being produced in the technology that we have today and as we go forward, right? Power consumption and power delivery is going to be key, right? So if you're looking at areas where we're certainly going to see more of an engineering effort, I certainly do think it's going to be around the thermals, i.e. liquid cooling, and then ultimately power distribution, how we get power to these systems.
Okay. I think we're pretty much done.
Oh, excellent.
But basically, we let all our guests to have the last word, to say anything they have on their mind, their perspective on the development of the industry, wherever your company is going, your personal goals.
Oh, well, thank you. Well, first and foremost, I'll tell you, I think we're at the infancy, right? I imagine the majority of folks you've spoken to today will tell you that AI is still in its very early stages, right? Yep. And so ultimately, how we see AI develop from the training aspects of where we are today, ultimately into the inferencing aspects of where we need to see it go inside the enterprise, there's a lot of evolution that's going to happen in a very short amount of time, right? And so I'm going to reiterate my comment earlier around partner, right? Really reach out to the ecosystem and understand how you're looking at and what you need to do to implement this AI. And then two, go back to the conversations we had around some of the things that Lenovo has done around leveraging AI responsibly, right? And you can use the 6 goals that we put together, but ultimately have those pillars or those goals inside of your own organizations to understand how you're going to use that responsibly, because there's a lot that comes with AI, and it's an exciting tool.
Yeah, I think it's pretty interesting how the perception of AI will evolve in the coming years, because we don't really know what's going on inside AI, so we're still discovering, I think, and we're trying things, but the fact, and it's one of the major concerns that we have seen with OpenAI, for example, that has shifted its non-profit arm towards for-profit, where people are asking themselves if AI will still remain a public good after all, or if it will only become a way to make more money.
Yeah. Again, I think it's all in how you implement AI, right? I mean, I don't view AI in a lot of the Hollywood views that people have seen on different movies and things like that. But again, AI can be used for some very strong things inside of our society and advance that. But it goes back to how do we actually leverage that, and are we doing that responsibly?
I think one of the questions I want to ask, I haven't asked yet today, do you actually use AI every day, or like in your everyday life or for your work?
I use it quite a bit. I mean, every day, it's probably close to every day.
Okay.
Okay. And different research. Now, I could probably be better at how I utilize all the tools of AI, but it's certainly becoming much more prevalent in the things that I do.
And is it something that, for example, Lenovo can actually use in order to find new designs or help out with some work in the future to be done?
Oh, I'm sure. I mean, again, we're at the tip of the iceberg right now, right? I mean, the idea around how you do design work and how you do test and everything else like that is still being worked out and still being there to understand. But Lenovo, like every company out there, will leverage AI and try to figure out how to make ourselves more efficient, make our products better, help our customers out in the long term.
Okay, perfect. Thank you very much, John.
Absolutely. Thank you.